Closing out is Christopher Tubbs. He's a researcher with the National Security Agency. He's been a longtime Accumulo contributor, PMC member and committer. He's going to talk to you about changes in the Accumulo 2.0 API. So with that, Christopher, all yours.
Thank you. Hello, everyone. I know it's the last talk of the day, and you guys have probably been to a lot of talks, so bear with me, and we'll get through this pretty quickly, I think. So I'm just going to give you a little overview of what's on the roadmap for Accumulo 2.0, and you may know 1.7 should be out pretty soon. 1.6.2 is the latest, but we are planning sort of for the long term. We want to make sure that the API evolves and we provide new features going forward. So that's what I'm going to be talking about. So just a little disclaimer, a lot of what I'll be talking about is sort of tentative. Not everything's been reviewed by the rest of the PMC, the rest of the committers. So this is still kind of early and sort of thinking about what we're going to be doing. Not everything's finalized yet. So just keep that in mind as we discuss this. And also, I'll use the word "we" a lot. Generally, I'm referring to like all the committers, the whole community. But you know, we're a community of individuals, so my opinions are different from other people's opinions. So there may still be a lot of discussions and debate about what API changes are going to be made going forward. So just keep that in mind. I don't mean to represent everyone's opinion when I use the word "we." So quickly, just a little overview of the current versions that are out there. We have 1.3 was the first released version in Apache, and 1.4 followed that. 1.5 and 1.6 are still out there, still current. 1.3 and 1.4 have kind of retired, and by retired I mean we're not really doing long-term support for them anymore. No additional bug fixes, or they're kind of feature frozen at this point. Or not just feature frozen, the code frozen. Some people may still be using some of those old versions, and we can certainly help out by answering questions on the mailing list and things. But as a community, we want to look towards the future and make continual improvements, and we don't want to be too much stuck on some of the old versions that are out there. 1.7 is not yet released. I put a question mark because I wasn't sure if it would be released by the time this talk was given, but hopefully soon. I think we only have a few tickets left. So, and when that happens, maybe 1.5 will go into the retired state. Typically, we'll maintain support for the last couple of versions regarding bug fixes and things. Currently under development, just started, is 1.8 and 2.0. For the long term, and obviously 2.0 is what I'm focused on today. So in the past, our versioning philosophy has been very haphazard, and many people have complained about this, so it's something we're very sensitive to. We don't want to make changes that break people's code. We know Accumulo is a library that people depend on for their own applications. And so in the past, we've had a habit of removing code that we've deprecated in one release and then immediately removed in the next release. And that's been a little rapid for some people. And we want to keep things more stable. So after many discussions on the mailing list and everything, we decided to adopt semantic versioning. The definitions of that are at semver.org. You can go check it out. But essentially what it means is that there are 3 components to a version number. The major, the minor, and the patch. And the major version is where you make breaking changes, you remove deprecated APIs. The minor is where you add feature improvements to the API. And the patch version is where you just make internal bug fixes. So that's really important because we want to be able to communicate what kinds of changes have been made from version to version. And in the past, we didn't do a very good job of communicating those kinds of changes. So semantic versioning gives us that ability to follow some very strict rules and convey exactly what our intentions are. So when you go from 1.6.1 to 1.6.2, you know that, hey, there's bug fixes in this. My code should still work fine. In fact, better because of the bug fixes, hopefully. And you know that going from 1.6 to 1.7, now you'll have additional features available to you. So, so going from 1.7 or 1.6 to 2.0, there may be some breaking changes. Old features that are no longer supported, deprecated, those will be removed. So that's what it means to have semantic versioning in place. So in the past, I would largely argue that Accumulo, like most projects, really focus on its core goals of scalability and visibility enforcement, authorizations enforcement, mandatory access controls, making sure that it functioned as intended, and less emphasis was placed on API and usability integration with other products. I think that's true of any early project, but as projects mature, more and more emphasis is placed on integrating with other products, and that's where we're at now with integration with Hive and Pig and all these other tools in the ecosystem. We want to make sure that our API is stable so we can integrate well with these other things. So the current API, the basic design for it has gone, well, the current API has evolved over many years, ever since 2008 when the project started. And most of those changes have been very gradual, small changes here and there, feature improvements, additions. The current implementation probably represents the biggest redesign, and even that was that was relatively tiny. Accumulo has always had this idea of the main entry point being a factory for objects, creating a batch scanner, creating a batch writer, and going from that connector to the actual functionality that you need. So I think it was around 2009, instance and connector kind of evolved to what they are now, where we had this idea that we had a connector, that's our factory, but we need to provide some configuration, some minimal configuration to provide to the connector so it knows where Accumulo exists on the network. And the way we did that was with an instance object. That's what's familiar, that's what's there today. I think also around that time there was a lot of improvements to the permissions and the authenticator and all that other stuff. But for the large part, Accumulo's API hasn't really changed. We've added a lot of features and a lot of methods have been renamed or added new parameters, but the overall design hasn't really changed. It's still been that connector factory that produces objects like writers and scanners. So our current API statement is, I should explain. Semantic versioning operates off of what they call the public API. So it's incumbent on individual projects to declare exactly what their public API is. So for Accumulo 1.5 and 1.6, this is our public API statement. Everything that is public and protected in the Accumulo core client package, except for any subpackages called impl, anything in the Accumulo core data package, as long as it's one of these specific classes that we care about, and everything in the mini cluster package, except for the impl package. So as you can see, our public API statement could use some work. It's a little better in 1.7, thanks to the efforts of Keith Turner. It's cleaned up a little bit. Now there are 4 main packages that we focus on and consider our public API. Those same packages, except for one additional one, the security package. And we just simplify the statement. These 4 packages and all their sub-packages, except for these few exceptions. So, so with that public API, we've had a lot of lessons learned from evolving it over the past few years. And the first one I want to talk about is just this instance connector concept. As somebody familiar with the API, I find it relatively straightforward, but I've heard from new people coming in that they don't really find this intuitive. For one thing, there isn't it's not obvious that an instance and a connector has anything to do with Accumulo as a client. It just doesn't convey that. Once you're told exactly how to construct a client, it's pretty straightforward, but it's not very intuitive. So we can do a little better. And originally, the client, or the connector, you had to instantiate the instance and the connector, and then you pass the instance as a parameter to the connector. So we treated instance as sort of a configuration object that gave information to the connector. Now, even the instance has become a factory to produce the connector, which is a factory to produce other things. So we have this chain of factories. Some of that could be done a lot better. Along with that, there's a lot of overloaded methods. For instance, in the instance, you can say get connector with this username and this password, or this username and this authentication token, or this username, this authentication token, and this timeout value, or get the connector with this client configuration object. All these overloaded methods add a layer of confusion to new people coming onto the project, and it raises the bar. What we want to do is lower that barrier to entry so people can quickly and easily write clients and start actually working on their analytic or their database operations. So one of the things that we've learned is instead of using all these overloaded methods, it's better to encapsulate things into a configuration object and then pass one parameter. That keeps the API relatively stable. The main entry points, like to create a batch writer, for example, it doesn't change over time. We may add new configuration options to, let's say, the batch writer configuration, but for the most part, the API is stable. You also get the same benefit if you use builders instead of configuration containers. So that's what I'm looking at with the new API. So here you can see this is a little better than the instance connector thing, I think. And the idea is that you call accumulo.client to instantiate a builder for a new Accumulo client. And on that, you can call the different methods for the builder, and then you can build an Accumulo client from that. This gives us a lot of advantages. We can add additional setters to set additional configuration options as the API evolves. And it also makes the builder, we can make the builder serializable or exportable to a configuration, so it's reusable. Basically all the benefits of a builder. And we can make that even better by making it fluent, so you can do some method chaining that improves readability and writability. So more factories, but not the factories of factories of factories that we had before, but just use the factory concept more often when it's appropriate, and use configuration builders or configuration containers and builders when appropriate. So that's one lesson learned. And then make it fluent. We found this very easy to write code when we make it more fluent. The batch writer config example I gave is an example of that, where you can set additional options in just one line. So another lesson learned is resource management. Not too long ago, I think it was last year, somebody had the idea of having an Accumulo client inside, I think it was a JBoss container. But the way the server worked, we needed to close one client and then instantiate others when it received new requests in the servlet. I don't know the exact details of that, but it revealed this big problem that we had. We're storing a lot of static stuff in the JVM in the client, and that stuff isn't accessible to the public API. You can't just clean up or close those resources. So we had to hack in a little bit of code to sort of kill all those extra thread pools and caches and things, so that way in the servlet container it wasn't using too many resources. That's a bit of a hack. We can improve that a little bit by making objects closable and giving users the ability to manage their own resources. Of course, we also want performance trade-offs. we want some performance, so we want to be able to reuse these thread pools and these caches and things across possibly multiple users and passwords. So with that in mind, the idea was to create an opaque resources object that a user can instantiate. They can pass that to the builder when they're constructing a client, and they can use those resources in the client. So instead of storing stuff in a static JVM, we store it inside of this resources object. The user has full control over this resource object's lifecycle. They can call close on it and no longer use it. They can share it with other clients if they need to instantiate multiple clients with different usernames and passwords, and they just want to share those thread pools. The implementation now is that if you don't specify a client resources object, then you just get one internally by default, and it gets cleaned up automatically when you close the client itself. If you pass one in, then we don't clean it up automatically because we assume that you might be using it with other clients, and the user is responsible for cleaning it up themselves. So this gives users a lot more control than they currently have over the internals. Even though we're not necessarily exposing direct access to those internal caches and thread pools and things, it gives users more control over cleaning up those resources that they are using. So another lesson learned, or I guess identification of a problem in the current API, is with regard to exception handling. So there's a lot of issues with exceptions. We have two main exceptions that I consider sort of top level. We have the Accumulo exception and then the Accumulo security exception. And it's not obvious, I think, when these are expected to be thrown. And in some cases, we just forgot to declare one on the public API method, so we had to wrap it with another one that was declared. Or we'd wrap it in a runtime exception. A lot of this was very inconsistent. So we want to make that better. We want to improve exception handling and give users more control over what to do when an exception occurs. Some of that gets a little bit better with Java 7 because you can use the try multi-catch block to catch multiple exceptions and do the same thing. But we can be better about that. And the one idea that was proposed that I think kind of stands out above the others is creating an exception hierarchy. So all our internal exceptions, table not found or namespace not found or table exists, they all extend some base exception. So the user can catch the base exception, or they can catch the more specific exception, depending on how precise they want to get with responding to those exceptions. It also gives you a little more control with distinguishing our exceptions from your own application's exceptions, because you can just catch the top level Accumulo exception. I think there may be, everyone has their own idea of exception handling, so I expect there's going to be some debate and discussion before any of that's finalized. Usually those debates involve quotes from effective Java, but I expect some discussion at least before that's finalized. But that's the basic idea. There's also cases where we want to, we don't have catched exceptions. We have runtime exceptions that we want to deal with. Because we're using iterable, and iterable on its, you can only throw exception or runtime exception on those. So there may be cases where we want to throw illegal state exception or illegal argument exception, or things that extend, that are built in. In those cases, I think we still want to have our own custom exceptions, but they'll extend some base reasonable exception. Like, for example, invalid table name might be an illegal argument exception, but it'll be thrown as an invalid table name. So you'll clearly understand what the problem is when you're debugging the log messages or the output of your exceptions. So another problem we've had is leaking non-public API methods and classes into our public API. For example, we may declare something as a public API method, but one of its parameters is something that's an implementation class. So the user still has to instantiate it and still has to have a reference to it. But none of its API is going to be guaranteed to be stable like the rest of the public API. So we want to be very careful that the only thing that we're referencing in our public API is other public API types, or something from an approved standard library like Guava or built-in Java types. So that's very important. And thanks to the work of Keith Turner, I want to make sure to give him credit. He wrote up some code that did some analysis on our existing API that evaluated all the cases where we're actually doing this, returning types that are outside the public API, or accepting parameters or subclassing types that are outside the public API. In all of these cases, it can really lead to problems in the user's application code. So he wrote the logic for evaluating our existing code, and I wrapped that in a Maven plugin, so that's available for you to use. And we actually ran that on Guava and detected one minor trivial issue, but it's kind of nice to be validated that your API checking tool actually works against other libraries. So that's there, and we run that now in the 1.7 build. And we've done a lot of work to move the existing problems, deprecate them, and replace them with new classes, new types, so that can be held much more stable, and we can have much better guarantees. Another problem that we've had is exposing too much implementation. For example, the MapReduce code, inside the MapReduce, we have the input formats and we have the output formats, but we also have the record reader and the input split and all those other auxiliary classes that come with implementing a MapReduce input format or output format. And a lot of those are just right there exposed as inner classes, public inner classes to our input format or output format. That really puts a lot of restrictions on what we can do when we want to change the implementation, because if we're declaring this as public API, we don't want to break anyone who's using it, who's extended it. So that's kind of limiting. So that's one thing that we want to avoid in the future. I think we still have some outstanding problems in 1.7 related to that. I don't know what our solution is going to be, but that's definitely something that we've learned not to do, and we're going to do better in the future. So some other problems. I want to mention this one in particular, the Guava beta annotation classes. Guava does a really good job of annotating its classes as beta when you're not supposed to use it, or not supposed to assume API stability with it. And Hadoop has a similar practice of marking things as limited private. So they may be public and accessible through the public API, but they have annotations explicitly declaring that you should not be using them or relying on their stability. Unfortunately, we sometimes do. Hadoop got into a little bit of trouble with this with the use of the beta annotation. I know a lot of people want to build on Hadoop, and they want to have a newer version of Guava with all the additional features that it comes with, but they can't because it breaks Hadoop, which also depends on Guava. And it was just because they were using this one limit input stream that was marked as beta. So that's something to avoid. We haven't come across that too often in our own code, but it's something to avoid and something we've observed as problematic as a user of those APIs, and we definitely don't want to do that to our users. So another problem with dependencies is bringing in a lot of transitive dependencies just because we want one little class. And the biggest problem is Hadoop text and Hadoop writable. Very useful classes. It's very nice to have a nice little UTF byte array wrapper that we can treat as an object and pass around. It's comparable and serializable. Very useful. We use it everywhere in our public API. But not all of our users need all of the transitive dependencies of Hadoop just to get that one type. So that's something we want to be cognizant of and avoid in the future. We want to maybe encourage Hadoop to put that in a separate like types jar or something that we can depend on in the future, or come up with our own. And it kind of sucks to create our own thing that was already invented like 12 other times in 12 other libraries. But in order to avoid this transitive dependency problem, sometimes it's necessary. It would actually be really nice if Java had a good baked-in bytes object. There's byte buffer, but it has limitations. But that's the kind of thing we want to avoid regarding transitive dependencies. We don't want to bring in stuff that comes with all this baggage. So another problem we've had is putting RPC and serialization library code in our public API, specifically thrift types. I don't know if you've seen, we have these two thrift methods to support our RPC implementation on a lot of our public API objects, like key and value. They have this to thrift, which is great. It's very useful because it defers the implementation for serialization into that object, where it has all the information needed to serialize itself. But it also puts this public method to thrift with these non-public types directly in our public API. So that's something we want to be aware of. We probably want to use more serialization strategies that do not require exposing specific internal classes in the public API. Because once we do that, then users depend on it and we're stuck with that dependency. We can never change our RPC implementation without also keeping the old RPC dependency around. So that's something we've done and we want to avoid. We've also exposed logging classes that relate to the implementation. We've recently gone through this large push to switch everything from log4j to SLF4j, so we can support logback and some of the other implementations of SLF4j. Unfortunately, we still depend on Hadoop, which has a direct dependency on log4j, and we use Thrift, which has a dependency on SLF4j. So we have this sort of hodgepodge of logging frameworks that are interspersed throughout our code. And I think Fluo depends on Twill, which has a hard-coded dependency on logback. So even projects that depend on Accumulo are going to have a headache with that. So one of the things that we can do is, regarding the API, is just make sure we don't put any of these implementation-specific classes directly in our API, like log4j's level class, which we've done. Because that ties us to one specific implementation and makes it a lot harder for users to control their dependencies when they're building on top of Accumulo. So another type with parameters, or another problem with parameters is these stringly typed objects. Table names, table IDs are a big problem. A long time ago, there was a table name, and table names were just fixed table names. But we had this idea, let's be able to rename a table. And so to do that, we had these fixed table IDs, which was conveniently also a string type. So we didn't have to change a lot of the internal code, but now the semantics of it changed. Now every place internally where the parameter was called table name, or more frequently just called table, the semantics changed from a table name to a table ID. That's great for easily implementing that new feature of being able to rename tables, but it really sucks when over time we forget whether or not this is a table ID or a table name, and then we introduce bugs because it's just a string. How do we know which one it's supposed to be? And of course there's no Java docs to explain, which is something we can do better at. But this actually bubbles up and starts getting exposed in our public API also. So it's not always clear whether or not this is expecting a table name or a table ID. So that's something we want to be careful with. I think, for example, key extent was something that was an implementing class that was not supposed to be in the public API, but was because it was a parameter to a public API method, and that had key extent had a public method that returned table ID. The table ID is just a string or a text object. So you might think it's referring to a table name, but it's actually referring to an internal table ID. So we want to avoid that kind of stuff too. It's even worse when we're talking about string objects as parameters, because a lot of these string parameters are actually serialized internally, either in Zookeeper or in R files or elsewhere in our configuration. And we have been relying on the default platform encoding, which can be different on every JVM. So that's a problem. Whenever we're storing stuff internally, we want to make sure that it has a consistent serialization with a specific encoding. So when we convert back and forth from strings, we always get what we put back in, or what we put in. So that we've done, I think we fixed all the problems that are outstanding with regard to that, but that's something that has happened. And going back to the overloaded methods issues, addressing encoding issues can often lead to more overloaded methods, because now you not only have a version of the method that takes a string as a table name, you also have a version of the method that takes a string as a table name and a second parameter for the encoding to specify what you want to encode this as when you store it. That creates unnecessary overhead, especially since the user doesn't necessarily have to know what the encoding is if this is just being stored in internal metadata. So we want to be careful with that, use consistent encoding, and avoid string types when it's subject to these kinds of problems. I gave a few examples where this has caused problems. Authorizations. Authorizations are compared against the visibility label. The visibility label, like everything else in the Accumulo key, is composed of byte arrays. But we really expect authorizations to be strings, human-readable strings. So when we're comparing these strings with visibilities, we need to make sure that we're doing so by converting the string into a byte array that is using the same encoding that the visibility label was written as. Otherwise, the comparison's not going to work. And using JLine in the shell, that uses native libraries, I believe, in Linux. So you may get platform encoding issues in the shell when you write something out to a table and then try to read it back. It may be using the Linux default character set, but when we read it back out in the Java API, it may be using UTF-8 or whatever the default is for your JVM. So to avoid some of these string type problems and the encoding, and also to avoid the overloaded methods issues, the idea here is to introduce some new types and promote some of these parameters like table name and namespace name as top-level objects. So I gave some examples, namespace and table. The idea is that you construct a new namespace by a name, and that's its current name. And then that reference, that object, always from that point forward references internally the ID. So even if another thread changes the table name, the table ID, this object that you created is still pointing to that same table that you intended. And if you really want to do the current namespace by that name, then you can create a new namespace object. So this gives users more control over whether or not you want to do operations on an existing namespace or whatever the current namespace is by that name. This also moves a lot of the operations in these factory methods that we used to have, these table operations. I say used to, it's still there in the current API. Just want to be clear, I'm thinking about the future. So in our current API, we have table operations, security operations. These are additional factories that give you additional functionality to do different things with tables. For example, instance.getConnector.get or .table operations .exists, and then pass a table name as a parameter. Well, if we can just get a reference to a table, we can just call .exists at any time. So it moves a lot of those factories up into the object we're actually controlling. It's a lot more object-oriented, and I think it's a little more readable when you start looking at code written this way. So it's also kind of unnecessary in the table operations. You're constantly passing the same parameter every time. The first parameter is always the table name. Namespace operations, the first parameter is always the namespace. So once these are promoted to top-level objects, first-class citizen objects, they are you can put these methods directly on them that allow you all the same functionality, but it's much more intuitive. So where is all this new API going to live? A new module, a new artifact that just contains the API. It doesn't contain implementation classes, just contains interfaces, abstract classes, and basic like POJO type objects with getters and setters. So, and a single package, org Apache Accumulo API and its subpackages. No dependencies on other Accumulo jars, so Accumulo will just depend on this. And the way that works is when we're using the factory methods in this class, we can bind to the implementing classes at runtime using Java Service Loader, which I've really begun to like lately. It's really cool. So no dependencies on other Accumulo jars. This really frees us up in the implementation to change things under the hood without necessarily changing the API. Also minimal dependencies on other stable libraries. We may depend on some commons, Apache Commons or Guava libraries, but for the API, but largely no other dependencies, none of the Hadoop ecosystem dependencies that may bring in all these transitive dependencies for users. So now instead of everything being just sort of a few packages in the Accumulo core jar, it's in its own jar, and you know exactly what to expect when we're declaring the public API. So the new API statement for 2.0 will just be everything that is public and protected, everything you can access in this package, this one package and all its subpackages. Alternative statement, everything that's public and protected in this entire jar. So much simpler and much easier to compare different versions to make sure that we actually conform to the semantic versioning rules that we've agreed on. So some of the overall goals for all this is to improve the API stability, make sure we can enforce compatibility and we can easily track changes to the public API. Helps users manage dependencies because now they can have a compile time dependency on our API without bringing in any of the transitive dependencies, and then just have runtime dependencies when they deploy their application on the necessary transitive dependencies. We can also separate the API from the implementation using like the Java Service Loader, like I mentioned. In theory, we could swap out the implementation. Maybe this will be a new version of mock or an in-process version of Accumulo that doesn't do all this RPC stuff. It may be easier to mock out or to create a new testing framework. That's just kind of a loose idea. We haven't really discussed that. An intuitive front door, just a class named Accumulo, accumulo.client. Can't really get any easier than that for the front door. Fluent usage, builders, being able to save and serialize configuration and reuse, better resource management. And the overall idea here is not to necessarily dictate a new API that, hey, this is the new API you need to switch to. The biggest goal, the one that we really want, is to set the foundation so that we can we can evolve the API over time without breaking people. And we know and those users know exactly what to expect. So as far as the release plan goes, obviously finish the implementation. There's a lot of it that's not done. And to get it reviewed and then eventually to put out an alpha release. The alpha release will be just something that we can say, here, it's available for testing, let us know. It's not necessarily API stable yet, but we think it's good enough to use. Let us know what you think. So that'll be our way of communicating with users that we really want feedback on how this works for you and get their feedback in and make changes before we finalize the release. Possibly a beta after that API is stable, and then eventually, hopefully this summer, final release of 2.0. So here's my contact information, my email address, GPG, and you can contact the mailing lists or find us on Freenode IRC. This is the parent issue in Jira for all the API changes for 2.0. There's a lot of good stuff in there, a lot of good ideas. I encourage everyone to check it out, look at the subtasks. If there's something you want to volunteer to help with, that's great. If not, you just want to comment on the existing proposals, that's good too. Any feedback or any help is always appreciated. So, any questions? So the question was whether or not I looked at any other dependency injection frameworks like Juice as an alternative to the service loader. I actually found the service loader to be fully sufficient for everything we needed. So I didn't look too hard, but I really like it. I did find a project that helped create the service loader files. I forgot what it's called exactly. Auto Service. It's a Google project. It just allows you to create the service files from annotations in your project. So that's really helpful. You just annotate, this is an implementation of that interface, and then on the build, it just creates the service loader files for you. Any other questions? Okay, thank you.